everyone. I would normally start this talk with question, who uses Hibernate and Spring Data, but I imagine everyone uses Hibernate and Spring Data, so it wouldn't make too much sense. So I will start it differently. Who has ever owned a Commodore C64? This is like way more than I expected. I got recently a little bit into retro computers, retro gaming, to remind myself good old times. And by the way, I have some technical issues, so I'm going completely off the script. So we will see how it goes. But the talk is about the performance-oriented Spring Data JPA and Hibernate. So no AI, no new stuff, no GraalVM, nothing super fancy, good old tech that we use since like 15 years or so. And during this talk, there will be some demos, some puzzles. I may ask you some questions. If you've seen this talk before, because it has been recorded already once, then please don't answer. But I hope they are a little bit tricky and you take something out of it. So, first of all, why are our applications slow? And what does it actually even mean that the application is slow? It usually happens that someone comes and says like, oh, you know, the application is not usable, it's slow, it's just uploading takes a long time. Customers are complaining. And we, as developers, are really great in finding good excuses for basically any problem. Like, if we don't write tests because the manager tells us to not write tests, to not waste time on it. If we don't deliver the features that are expected, we blame it that there are too many meetings. And when things are slow, we also find something to blame. And like 20 years ago, it was a common thing to say that just Java is slow because everyone who ever used Java usually used it on the desktop, so had like OpenOffice or Eclipse or something like that, and on desktop Java was actually really slow. Nowadays we know that Java is quite the opposite of slow, it's actually extremely fast, so we can't really blame it. So another suspect is the database. And of course the database, maybe it's not even slow, but because we have so much high traffic, so lots of data, it's very easy to say that, well, the database is just underperforming. And that's very easy to prove if you have any sort of monitoring. You can say like, oh, you know, the database CPU or the I/O is just going off the roof, and, well, what we do? We just have to get a bigger database. And this is relatively easy in the era of cloud computing. We just, you know, pay another thousands for the bigger database. If it's not the database, it could be the framework, because the frameworks we use are super complex, like a layer of complexity, and obviously they must be slow. But the reality is that it's not Java, it's not databases, also not really frameworks, but most often it's the way we use all of these technologies. This is what's making it slow. I work as a consultant or a contractor, so I've seen in my life several projects, and all of them, or at least the ones that end up in a success, and they are actually used, because some of them were, you know, canceled before anyone saw them live. But the ones that were successful, sooner or later, they hit some sort of performance issues. And from what I've seen, it usually boils down to this. There's either poor connection management, and then the application basically gets stuck and becomes completely unresponsive. The application, pretty much every application, issues way too many queries to the database that they actually need. It also issues very slow queries. This is usually because the queries are slow because of lack of proper indexes. Too many queries are very often caused by wrong JPA mappings. And also, because the way we use JPA, we fetch way more data than we actually need. The number one rule when fixing any performance issues is that we shouldn't guess. Because it happened to me as one of the first tasks that I got when I got like a proper job, let's say, was to optimize some JavaScript tree. It was like a time before even jQuery. And it wasn't completely clear. Like, if it's the problem is on the JavaScript side, the problem is on the backend side, and so on. And I had no idea what I'm doing because I was like 22. And I spent basically 2 weeks fixing it, and I fixed it. Like on the test environment, I showed that now it, like, instead of loading for 15 seconds, it loaded like in 1 second at least. So it was a huge improvement. And it took me around 2 weeks. But after these 2 weeks, we deployed it to production, and it actually was slower than before. But I had no idea what I was doing. It was like 2007. We had literally zero monitoring. I don't even know if we had any access to logs on production, anything like this. Now we have much better monitoring tools, much better capabilities of finding out what is actually going on. And one of the ways to do it is to use something like a distributed tracing, or even not distributed, let it be tracing for the one single service. So this is a screenshot from the Datadog APM from one of the production applications that I've been working on quite recently. The purple rectangle, each of the purple rectangles is the one query to the database. And this whole thing is just an execution of one single HTTP request. So you can see that it is over 7 seconds. There are quite many queries, but it actually gets even worse. If you would zoom in, each of these bars is also consists of few more queries. So overall, there were thousands of queries to execute this HTTP request, so it's not like a big surprise that it took 10 seconds. But the problem is, not that it was, I mean, one of the problems is, of course, that it's so many queries. But the bigger problem was that the code that executes these queries looks very decent. When you look at it from the code point of view, it makes sense. It expresses the business intent, it operates on entities, it has some repositories, and if I wouldn't have a way to look into the trace or look into something else, but traces are super convenient, I would just never know that this is actually happening. So, one way on production definitely is to look onto traces. But we shouldn't postpone the investigation of the performance issues to production. We should try to find the potential issues as soon as possible. One way is to just turn on SQL logging, and then when we run the tests, we will see what is executed, if it matches what we actually expect. Another way to do it is to use something like Digma. Digma had a booth at the conference, so maybe you had a chance to talk to them. They have a plugin to IntelliJ where it shows the potential performance issues already in the code as some sort of like a extra annotation on the method that is potentially harmful. I will try to show Digma a little bit later. All right, so let's start with the database connection management, because before the application can issue any sort of statement to the database, it needs a connection. That's something that we don't often think about, but I think it's quite important and also interesting to learn how does it work under the hood. So the application goes to the data source, then it goes to the JDBC driver, and the JDBC driver actually makes the network connection to the database. And we know that network is usually something that is slow, or at least it's much slower than the regular in-process call. And in this case, it's not just the network call, but it also has to do the authentication. So we can very easily, on the other side, on the database side, it's also quite expensive. So in terms of Postgres, each of these connections creates a new operating system process that takes some RAM. And if we have many of these processes running, then the Postgres server has to switch context between these processes. So it's also heavy on the database side to have all of these connections all the time open and closed. So we can very easily end up in a situation where we have a relatively fast query, but it takes 100 milliseconds to establish the connection. I think you don't have this issue anymore. I used to have them before Spring Boot was out and before all of these database connectivity things became a standardized thing. Now we use connection pools, and how the connection pool works. On application startup, it creates a pool of these physical connections. So the expensive call over the network happens on application startup. It creates like couple of, or by default, it creates 10 connections. And then whenever application needs a connection, instead of going through the network to the database, it just takes the connection from the pool. So in this case, there is no network, and acquiring of the connection is very fast. So we achieved exactly what we needed. But the problem now is that before, we would create a connection for every HTTP request. Right now, we just have a pool of 10 connections. And once all of these connections are used, then it means that when there is a new HTTP request coming and it asks for a connection, it has to wait until one of these connections becomes available. So our job as developers is to make sure that we don't use or don't occupy the database connection when it's not needed. So that we should acquire, use it, release it as soon as possible. But how can you tell when the connection gets acquired and when the connection is released? Usually you don't even see it in the distributed tracing, unless you do some tricks. But by default, it's just like a hidden information. And Spring Boot doesn't give you any tools to, or at least out of the box, it doesn't give you any tools to find it out. Fortunately, there are some third-party solutions that make it possible. One of them is Flexipool, made by Vlad, that we all know and appreciate. So Flexipool is a more like a tool to find the proper size of the connection pool. I am going to use it just for its logging capabilities. But Flexipool is not very easy to use with a Spring Boot, like off the shelf. So I'm going to use also another project by Artur Hawliukowski. It's a Spring Boot data source decorator. This is like a project that lets you integrate different types of tracing, logging wrappers around data sources to give you some extra information. One of them is Flexipool. There's also P6 Spy, and there's also data source proxy. All right, so let's now switch to the code where these kind of problems with connection management do exist. I think it's good enough, right? The size and so on. All right, so the project I have is a totally like a sample made just for the conference. Nothing really fancy here. It's a typical Spring Boot application with some extra dependencies to have these logging capabilities. In terms of configuration, I'm using Postgres. I just, for the convenience, I create the database schema automatically. I have a logging turned on. I just have a, also this is for the Flexipool logging. Nothing really special configured here. And then I have a service. So a typical service that represents some sort of the business processes. In this case, it doesn't do anything useful. It has a bunch of transactional methods. Each of these methods goes to the database, sometimes makes something extra. And then there is a controller that calls these methods. And then I have a test that hits this controller, and we should see when the connection got acquired and when the connection got released. So let's see how it works. Okay, so here are the logs, and I'm getting from the Flexipool that the connection got acquired in 2 milliseconds. This is not so important how long it took. It's always super fast unless the pool is already exhausted. Then what happened? So in our case, it's just a call to the database to fetch something from person table, and then the connection is released, and it tells for how long the connection was released. And in this case, it was released for 273 milliseconds, which seems to be a little bit too long for executing this one single query. We have marked it as a transaction. Also, we want Spring to create a transaction. We also say that, yeah, this is where I'm going to use the database connection. So I would normally expect that, this should be relatively fast. So what is happening here? Do you have any guesses? Pardon? Well, this could be a good improvement, but not in this case. Pardon? Also not. We will get to eager fetching at some point. I briefly shown the controller, and in this controller, when we hit the hello endpoint, we call the service, but also afterwards we call the external service. So let's imagine it does like an HTTP call or something. In our case, it just makes a sleep. It seems like the sleep is also included here. And that's exactly what happens. When you run a Spring Boot application, you will see a warning about the Spring JPA open in view. And it says that database queries may be performed during view rendering. It doesn't somehow resonate with what we are doing here because we are not really rendering any view. But the side effect of it is that the connection to the database remains open until the execution of the whole HTTP request is over. So it means that when we enter this method, it opens the database connection. Then the transaction is actually committed, but the connection remains open. And this external call is also executed while occupying the database connection for no good reason. So the first thing that we should do in pretty much every Spring Boot application is just to disable the open in view. And once this is done, the transactional block will actually control when the connection is acquired and when the connection is released. So now this time should be much, much lower. Now we can see that the connection was released just for 61 milliseconds. So that's the first step. And many of the production systems that I've seen that are already working for a long time don't have this flag turned on. And you can see the spikes in the connection usage, and sometimes the application, the requests have to wait for the connection to be acquired. Let's take a look at another one. So now we have just to show that there are no traps in the controller. So in this case, it just calls the sample service with external service call. So we have again a business process where within a transactional method we have to call the external service. That's kind of like a common thing that happens. And obviously, when we enter this method, the connection will be acquired. So again, we are occupying the connection without any good reason here. And we are quite lucky because the call to external service is executed as the first thing. And we can do another trick. We can go to application.properties and tell the data source to turn off auto commit. And just let me go to the test and run it. So the auto commit mode that is turned on by default means that you can commit to the database, that it just commits to JDBC driver commits to the database automatically. And that's anyway something that we really don't want, right? If we are writing like a serious application, we want to have a control over transactions and control over when the commit happens. So if we turn this off, the side effect of it is that it will acquire the connection not when it enters the transactional method, but when the first interaction with the database happens. So now if I look at the logs, it's again, the connection was leased just for 12 milliseconds. So this external call didn't play any part in it. That's probably, again, like these two properties are probably something you should set in every new application you create that uses any relational database. Here we were in quite comfortable situation, right? But the external call happened before we interacted with the database. But more often than not, first we have to fetch something from the database to actually build some sort of payload and pass it to an external service. And this trick, unfortunately, doesn't work anymore because here Spring just cannot know if we are going to interact with the database later or not. So what can we do about it? One of the lesser known features of Spring Framework is the programmatic transaction management. We always use the transactional annotation. That is very convenient. It's a very nice feature, but there's also the other way to create transactions. This is called transaction template. So with transaction template, it has basically two methods. One is the execute and another one execute without a result. If it is meant to return something, then we call execute. If not, then execute without a result. In our case, we will just do execute without a result and then pass whatever we need a transaction into the Lambda. And this will behave exactly as we expect. The transaction will be created here, committed afterwards, and then the external call to external service just happens outside. I think this is super important point because it often happens that we have some business flow where we want to have one transaction, do something, then do something else, then do another transaction, and structuring it with the at transactional annotation usually forces us to create some artificial services. And there is a one layer of services calling another layers of services, and in the end, you don't know even anymore what is a service. So by using this, you can create just these blocks within the method. And I find it much more convenient than using often transactional annotation. The case that I had quite recently is I've been working in a project that uses quite a lot the transactional with propagation requires new. What does it mean? When we look into this method, again, when it executes it, it will open the database connection, start the transaction, execute something here, but when it executes this method over here, it will need a new transaction, so it also needs a new connection because you can't have two transactions working on a single connection. So what happens is something that is quite nasty. Now if we look at the logs where we executed this method, it acquires the connection, issues the select, but then it acquires another connection when it enters this method, issues another select, then sleeps for 100 milliseconds, and then releases the inner connection, and then afterwards releases the outer connection. So it means that the outer connection, for no good reason, had to wait for the inner connection to finish. So we occupied two database connections overall. And if you put this requires new in pretty much random places and you have different layers of services, you can even end up in 3 layers of these connections where you occupy 3 connections at the very same time. And remember that by default, the connection pool is just 10 connections. So if you have 3 requests running like this at the same time, the 4th request will already have to wait for the database connection to be acquired. There is no straightforward solution to this problem. The one that I try to do is just to not use it and structure the code in a different way. So again, here we can say that I don't want this whole method to be transactional, but instead I will just use the transaction template and execute this part in a separate transaction. And this will be executed in another transaction because it's also annotated with transactional. This may not work for every case because sometimes maybe these nested transactions are really needed. But I really think that in most cases, you can avoid it. Okay, once we had the connection management done right, and I'm pretty sure that if you would look at your production application, you will find these cases where you can optimize it. Let's move to a proper Spring Data and Hibernate. So like a second part of the demo, completely unrelated from the connections. Let me just comment these things out so that we don't get too much noise in logs and see at the application. It is a simplified banking application. We have an entity like a core, the most important entity is bank transferred, and this represents like a banking transaction. And it has a sender, a receiver, both refer the account entity with many-to-one annotation. It has some amount, it also has some state. Then there is an account entity. No, this is not the one. This is the one. And it's an account entity. Again, there is nothing really fancy going on, just a regular JPA entity. And I preload this some data on application startup so that we can run the use cases. And one of the use cases is where we register a bank transfer. This means that we have received a notification from the payment network that the transaction happened, and we want to save it to reflect it in the banking application. When you look at this use case, what you would expect to happen from the database side, like how many queries would be executed, how many statements. When I look at this code, and this is, by the way, like very decent code, it fetches the account. So I expect one select happening here, fetches another account, so the second. Here I'm just creating a new Java object, and then I'm calling a save, which would result in an insert. But when I run it, the results may be a little bit surprising. It starts pretty good, right? What I said before. We have two selects to the account, but then something completely odd happens. It has a select to the bank transfer table, where it joins the account again, and it searches it by ID, and then it fetches accounts again. And then after all, we have this insert that we expected. Let's start with this suspicious select. What happens here? This happens before we call the save method. When we call the save method, what happens under the hood, Spring Data calls the JPA, simple JPA repository, and it calls the save method. And depending on if the entity is considered new, it either calls the entity manager persist or it calls the entity manager merge. How does it know if the entity is new? The default behavior is that it looks at the field annotated with an ID. If the ID is set, then it means that it's not new. If the ID is null, then it will execute the persist. In our case, I don't use here any generated value. I assign the ID manually because I want to use the ID from the payment network as the ID of my entity. So that's why it thinks like, oh, this is already an entity that exists, but I must make sure if it actually exists. So I will just make a select to the database to find out that if this data actually is there. I can change it by adding the version column. That's like one way to do it. Once the version column is there, this entity information is new, it will look into, okay, so I will look into the version. If the version is set to null, then it means that it's a new entity. But this, of course, means that we also have to add the column to the database, which is anyway probably a good thing because the version is very handy when you want to do some optimistic locking. The alternative is to implement an interface called persistable. And this interface has a method isNew, where we can define our own custom logic to tell Spring Data if this entity should be considered as new or not, and depending on that, call the persist of merge. Here I will just stick to using this version column. What else can we do to improve it? If you look closer, you will see that this is not annotated with @transactional, and it has certain consequences. So when we call the repository, it goes to the database, but it also, since we are using JPA, it creates a Hibernate session. It fetches the entity, and then the Hibernate session is over. So the entity is not managed. So the same happens here. And then we want to persist a bank transfer with two entities that are not managed. So again, it has to make sure that do these entities actually exist, and that's why it triggers two more selects. So if I annotate it with @transactional, and we'll run this test again, we should see, or I hope it will work, there will be just two selects and one insert, as we expected at the beginning. Do you think we can improve it somehow further. Pardon? Okay. Well, yeah, I mean, this could work. But we can avoid any query. We can just get rid of all the queries and leave just an insert. Because when you look at what happens with these account objects, nothing really useful. We fetch them just for the sake of making the JPA happy to have these relations here, right? We don't read any data, we don't use this data, we don't modify accounts. It's just for the sake of having the reference to the correct account object. And my account repository is not like just a regular CRUD repository. It actually extends from the JPA repository, which is a specialized repository just for the JPA. And the JPA repository has one interesting method, which is called getReferenceById. And getReferenceById is kind of like a trick, because it doesn't result in any query to the database. It actually creates sort of like a proxy object with this ID that serve exactly this purpose. We just need a reference. We don't need an actual object. So now if I run this again, hopefully, now for sure, I run it like 1,000 times. Right, good. So now we have just a one insert. There's of course a side effect, because before I had like find by ID or throw, so it means that if this account would not exist, I will get a proper exception. And now if this account doesn't exist, assuming that I have a foreign keys in the database, it will only fail here when I call the save. Still, it is somehow manageable. You could argue that we shouldn't have references to account here at all. And instead, we should just have, let's say, a sender ID, and it also shouldn't be a string, but some proper object. And then we would follow more the ideas behind the Spring data to not do cross-aggregate references. But from what I've seen, most of the time people use it as more like a JPA way. So yeah, so there are these references with many to one. Good. Okay, so let's stick to it, and let's say we fixed this use case. Good. All right, I will move on. Then we have another use case, which is when the bank transfer settles. It has a similar problem with this transactional, so I'm not going to repeat it. Let's run it to see what queries get executed. There should be one select, then the settle method just changes the state, and then we call save. It should result in an update. And this is exactly what happens, which is a maybe nice surprise. When we look closer to the select, it gets from the bank account, and then it joins the account to fetch the receiver, and also joins account to fetch the sender. So whenever we fetch this bank transfer, it has this longer join to fetch the whole complete aggregate. And this happens because these accounts are annotated with many to one that by default has a fetch type set to eager. So it means that whenever we need a bank account, also fetch the accounts. And maybe this makes sense to see this aggregate as a whole. I don't know. But the problem is that it's not exactly always like this. Let's take another look. When we want to fetch, we have a bank transfer controller, and this controller looks for all the bank transfer by sender ID that goes to repository. And again, it fetches the bank transfer by sender ID, then it does something that is completely ugly, right? It takes these objects and maps them to some DTO, and then the controller it gets serialized to JSON. What I would expect to happen on the SQL queries, there should be one query to fetch the bank transfer and make these joins and query by the sender ID. And that's what I'm talking about. So that's the query, but it actually fetches the account on the sender side only to make the where clause happen. What happens later is that for each of the entries in the list, it executes 2 more queries. So we end up in a situation that for the bigger the result, the more queries we execute. And this is so-called an n+1 problem. And that's something that can totally kill the database performance, even if you don't have a high traffic system. So the way to fix it is to change these mappings. Always when we have a many-to-one or many-to-many, we should change the fetch type to lazy. And then we have to be very explicit when we make the query what parts of the bank transfer, what parts of the entity we want to fetch. So we should always put this custom query annotation and write the query ourselves. So we will say that I want to join fetch the sender, I want to join fetch the receiver, and where so now I'm very explicit. And for each use case where I have these complex graph of database entities, I have to be very explicit which parts I want to fetch to avoid this n+1, but also to avoid overfetching more data from the database that is actually needed. And we ended up with this one query as we expected. When I look now at the bank transfer controller, I was hoping to see something here, but for some reason I don't. That's because my IntelliJ crashed before. All right, so we will just skip it. Okay. So to summarize this part, we need to remember about this open session in Vue and about the auto commit. Make sure that we call the transactions full, call the external services outside of the database transactions and also not occupy the database connection. Avoid this requires new and use transaction template whenever you need it. On the mapping side, avoid this select on insert. Remember that there is something like get reference by ID. Always set the fetch type lazy. Be explicit about what we are fetching. Oh, and then there was the dynamic update that I didn't mention, so let me go back to it. Okay, when we have this settled bank transfer use case, we are updating just the state. So let me run the test again just to see what happens. But when we look at the update that gets executed to the database, almost every ORM, including Hibernate, will just set the values for every column that this entity has. And this may or may not be an issue. If we would like to tell Hibernate just update what is meant to be updated, so basically write a query that I would write myself if I would write just a plain SQL, we can annotate this entity with a dynamic update annotation. And then it will not only track if the entity has changed, but also which exactly fields have changed. If you think that it will make like a big difference in terms of performance, most of the time it will not. Because let's say in terms of Postgres, anyway, when we execute an update, Postgres anyway inserts the completely new row. But it may make a difference if you have a table with large number of columns or with columns that store a big chunks of data, like some JSON or some binary data. So that's an option. I don't think it should be used too often, but sometimes it may be very handy. All right, so once we have this, the typical problem is that you've learned something, you fix it, you apply all of these things, but you have also other teammates, or maybe you go for holidays and someone just breaks what you've done, and you end up in the same situation later, and you come back from holidays and have to fix it again, and eventually you just give up and ignore these issues. Well. So there are some tools. Again, one is from Vlad. It's Hypersistence Optimizer. This is a very, very nice library. You attach it as a jar, and then you create a test. And during the test, the Hypersistence Optimizer looks into all the mappings you have, all the configuration on your data source, and finds what is wrong. So the Hypersistence Optimizer would tell you, you should set the open session in view to false. You should turn off the auto commit. You should fetch the many to one annotations to lazy, and many other things. This is a commercial tool, so you would have to buy it. And I know that it may not be extremely easy to buy anything in a bigger company. There are some other tools with a small asterisk. One of them is QuickPerf, made by Jean Bissuti, and that's the one that I will show you how it can help you to make sure that the thing that you actually intended doesn't get broken. So let me take a look at another test. It does something. It's not so important what happens under the hood. But this QuickPerf has some super simple and super handy annotation. You can say that you expect that during this method execution, during this test, you expect that there will be, let's say, 2 selects happening. You expect that there will be a 1 insert and maybe expect 0 deletes. Under the hood, it will track all the interactions with the database, and it will check at the end if it was met or if it wasn't met. And if it wasn't met, you will get a decent report on what is not right. You will see all the queries that got executed, including the parameters. The asterisk that I mentioned is that QuickPerf is not maintained anymore. So you have to do some tricks to make it work with Spring Boot. So if any of you wants to get into open source, maybe you can help to keep this library alive, because I really find it very handy. Okay, so there are quite a lot of things that are about the JPA entity Spring Data that is problematic, right? It's easy to make mistakes. This thing is a little bit heavy, right? It's you often end up situation when you fetch more data than you need, even if you just, when we have this settled use case, right? We wanted to update one field, but we fetched much more. We store the entities internally. JPA Hibernate stores it in the persistent context that occupies the memory. Then it tracks if it changed or not. So there is a penalty on the CPU. Then we have this risks of n+1. So what is actually good about entities is that you can implement the proper object-oriented programming and implement the business logic inside your entities and enforce invariance, make sure that the application doesn't get into invalid state. So it means that the point of fetching the entity is not to read the data, but actually to modify the data. When we want to modify the data and make sure that we transition the entity into another state, this is where the entity is useful. But when we just want to fetch the data for the sake of reading, like responding to all the GET requests, we should fetch projections instead. And projections don't have so much, are not as popular as they should be, even though there is a very nice support for them in Spring Data. So the typical scenario, we have an entity like the one above, but we want to return in the response something that is slightly different. It's like a subset of it. So that's the payload that it's expected. We could fetch the entity, and then we map it to a DTO with some mapping framework, but it doesn't make sense because we could do instead something different. We can create a projection class, or even better, a record, define it, which fields we are interested in, then create a repository method that returns this type, and Spring Data is able to figure out what it should do. So it looks into the structure of the DTO. It looks at the method name to find what is the where clause, and just as a reminder, that's how the DTO looks like. And then it will create a query that contains only the data that we need. So that's, you eliminate this problem of fetching more data than you actually need. If you don't want to use this automatic conversion from the method name into the JPQL query, you can also write this query yourself. You can even write a native SQL query if you would want to, with the one thing that you can't use records anymore, and it must be an interface. And if you have these DTOs that are not so trivial, it gets a little bit a little bit tricky. And the last resort is you can always just implement completely custom method on the repository, write the SQL yourself, execute this query yourself. It's still better than overfetching data with entities. And once you start getting into this habit of creating the dedicated projections for the use cases that you need, you will very likely end up in a situation when you have a lot of different projections. And the list of the repository methods will grow, and it will become difficult to look at. You will start to having problems with how should I even name this object, right? Because the DTO is kind of like, okay, I mean, it's not so meaningful, but at least everyone knows what it means. And then you start doing some completely bizarre names. So the Spring Data has another feature called dynamic projections, where we can define just one method on the repository, and then we pass the type that we want to fetch in runtime. So in this case, if we want to have a fetch by ID, but we don't know what do we fetch by ID from the repository point of view, we just keep this one method. That's a glitch. But the only problem with this is that now we have to rely on the Spring Data to resolve the where clause from the method name. We cannot write anymore our custom JPQL query. And the alternative to this whole world is to not use Spring Data and Hibernate at all. Because while this is very convenient, the great benefit of Spring Data and Hibernate is this object-oriented paradigm, the domain-driven design building blocks and the philosophy that Spring Data gives you. But if you use the JPA just as a dummy data classes, probably the overhead is just not really worth it. And maybe you should either resolve to Spring Data JDBC, or maybe you should resolve to Juke or just to write SQL yourself. Because SQL is also very convenient. Nobody really forces us to use JPA. The takeaways I would like you to take is that the JPA and Hibernate are not easy, and Spring Data, by the way, too, right? I mean, it all looks easy, but there's a lot of layers of abstractions and complexity under the hood, and you just shouldn't take for granted what you see, because what you see doesn't really what you get in the end. You have to get the connections management right. Use logging or Digma or any tool that will help you during development to avoid putting these potential production problems to production. Consider getting Hibernate Optimizer or contribute to QuickPerf to fix it for the newest Spring Boot version. And definitely use projections for reading data. At the end, big thanks to these two gentlemen, because most of the things that I learned about the JPA and Hibernate is from their blog posts or videos. And this will be it from my side. Thank you.
Initialize Genesis